This is Chapter 9, Problem 61. In this problem, we're going to have a perfectly elastic collision between two masses. That means we're going to have energy and momentum conservation. What's different about this problem from the typical ones we've done is that we know m1, 0.34 kilograms, and we know its initial and final velocity, 1.2 meters per second and 0.66 meters per second respectively. We don't know the second mass, and we know that the second mass starts off with an initial velocity of 0, but we don't know its final velocity. We're going to use the shortcut to figure out the final velocity of the second mass. Remember that the shortcut is v1 initial plus v1 final is equal to v2 initial plus v2 final. v1 final and v1 initial are known to us, so we have 1.2 plus 0.66, that's equal to v2 initial is 0, and we're trying to find v2 final. Now I did this the long way before, I didn't actually use the shortcut, so the answer is a little off, a little bit of a rounding error, but you should get something that's about 1.85 or 1.86 meters per second. It's okay to be a little off there. Now we're going to use momentum conservation to figure out m2. We start out with P initial is 0.34 kilograms multiplied by 1.2 meters per second. There's no momentum in the second mass to start. Then we have 0.34 times 0.66. And we're trying to find M2, and we just found V2 final as 1.85. 1.85, just barely fit it. And we can solve for this and get that M2 is equal to 0.099 kilograms. We know that the velocity of the center of mass will not change because we're dealing with only internal forces right now. So you can solve for the velocity of the center of mass any way you really want. I'm going to choose to do it before the collision. Velocity of the center of mass is equal to 1 over the total mass times the sum of each individual mass times its velocity. So this is going to be equal to, we just found the total mass of the system, that's 0.34 plus 0.099, and now we need to multiply that by, m1 is the only thing that's moving at the initial start of the problem, so that's 0.34 multiplied by 1.2 meters per second, and the velocity of the center of mass is equal to 0.93 meters per second. Again, you could solve this before or after the collision. It should not change because we're only dealing with internal forces, and that's a nice way to check yourself on this problem.